Okay, so we left off on being able to rearrange this universal law of gravitation formula to find other variables like distance, d or r. We use d. So here's another example that we're going to go over. The gravitational force between Earth, we already know this, and a satellite, we don't know, it's 2.19 e to the uh, third, third kilogram is 681 newtons. So this is the F of G. So what is the distance? So what we know, F of G is 681 newtons. M1, which is Earth, we know this from the last one. M2, which is that satellite, 2.19 e to the third kilograms. And the gravitational constant, which is 6.67 e to the negative 11th Newton meters squared over kilograms squared. So you remember how I was talking about distance? Or sorry, excuse me, units. So you see this divide symbol. That means that the kilograms squared is on the denominator. So when we get to the end product, we can cross this kilogram out, we can cross this kilogram out, we can cross this kilogram out. And then we've got Newton meters squared. So what else do we have in here that is similar? We've got N, which is newtons. So we'll get to the end of this, we'll be able to cross that N out. So we'll get the newtons out of there. And the last thing that we'll have is meters squared, so D squared. That's like what we always have. So, or it's D squared plus whatever exponents we have. But that's how you get through it with getting rid of units. Here, we'll go back here and figure that out too. So we'll get rid of the kilograms, boom, gone, boom, gone, boom, gone. Then we'll get rid of what we got here, meters for distance. We'll get rid of that meter, we'll get rid of that meter. So what we've got left is newtons. So you can see at the end here, our last unit is newtons. Okay, so we know that meters is going to be the last unit, so we can take all the units out, which I did not do on this one, I guess, but that's okay. So what do we need to do for D? What's the formula? Well, let's go back here. Remember, this is D. So D equals gravitational constant of mass 1 times mass 2 over the force due to gravitation. So we know all those things other than D. So we put in D equals the square root of the force of gravitation times mass 1 and mass 2 over 681 newtons. So then you can just all you got to do is plug this stuff into a calculator, and then you get the distance is 3.58 e to the 7th meters. So this is a long distance away from the satellite to Earth. Okay, so gravitational forces of Earth. The gravitational force of Earth is basically the thing that pulls things towards the center of the Earth if you're on Earth or in its gravitational orbit or field. So things fall from, we put fall because they're not really falling, they're being pulled from the acceleration due to gravity at 9.8 meters per second squared. This is Earth's gravitational constant, or the acceleration due to gravity, excuse me. This is Earth's constant acceleration due to gravity. What changes this is weight. So equal and opposite forces of the ground and our muscles keep us up from falling like into the center of the Earth. That's why we're not pancakes, because we have muscles, and then the ground also pushes an opposite force away. So weight, that's going to be the downward pull of an object's mass due to the force of gravity, and mass is just the amount of matter in an object. So the mass on the moon is the same, or the mass on Earth is the same as the mass on the moon, but the weight on Earth will be more than the moon because the Earth has more of a gravitational velocity than the moon does. So if you're 40 kilograms on Earth, you're going to weigh less on the moon. So your weight, really, all that is just how much mass you've accumulated on your body, and then plus the force of gravity pulling down with its velocity on Earth. So, it's just mass. That's your weight. It's how much mass you've accumulated. So you keep piling stuff onto your body, then you're going to weigh more. It's really simple. So from the sea level to the center of the Earth, the distance is 6.3781 e to the 6th meters. So that's just something you're going to need to know. So here's an example. Our variables that we're going to need to know are the force due to gravity, the mass, and our acceleration due to gravity. So this is G, or it can be V. So V is velocity, either one. Our formula here is going to be kilograms times meters per second squared equals newtons. So this is meters per second squared, this is newtons, and this is kilograms. So if a girl is 40 kilograms on Earth, we're going to plug that into here. So 40 kilograms right there, 9.8 meters per second squared. We know that that is our velocity of gravity on Earth, and that's going to equal 392 newtons. Okay, so let's do that for the moon. The moon's gravity, acceleration due to gravity, is 1.6 meters per second squared. So we're going to plug in 40 kilograms. We're going to multiply that by 1.6 meters per second squared. And you get 64 newtons. That's how much your force is on the moon rather than on the Earth. So you weigh a lot less on the moon. So then here's just a good example of that. This looks like this is the Earth's force, or the Earth's kilograms here, and this is your kilograms. And so you go through the gravitational constant, and then over the distance to the center of the Earth. This is how much gravity is being applied to you, the force of gravity which is being applied onto you from the Earth. So then you'll just go through that equation, and you end up getting 685.54 newtons. So that is going to be way back here how we're doing this. We're getting f of g. And then so we can put those numbers in. This is the distance from the surface of the Earth at sea level to the core. This is going to be your weight. This is going to be the Earth's weight. And then this is the gravitational constant. So that's all that this is right here. So go ahead and replay this PowerPoint as many times as you need to figure that out. Okay, and that's going to be it. So other than that, have a wonderful weekend. If you have any questions, comments, or concerns, you need some extra tutoring on this subject. It's not going to be super important for the quizzes or the unit post test, but the overall concepts are, like, the inversely proportional thing, the directly proportional thing. You're going to need to remember that kind of stuff for the quizzes and the unit post test. And then there's going to be a couple examples like this. So if you need any help, make sure you let me know. Otherwise, if you don't self-advocate, then I don't know that you need it. So have a wonderful week.